average power associated with an inductor. Now we know that in case of an inductor, when we supply the current, an induced EMF is developed which is opposing the increase in current. So to build the current in the circuit, we need to supply some energy from outside so that it can reach to maximum value. And we also know that that work is given by W1 by 2 L I naught square, right? And when the current decreases from maximum to 0, again we have to supply the energy. So basically overall, if we see that the total average power associated with an inductor should be equal to 0. Now in this video we will prove that the average power associated with the inductor is 0, and moreover learn how, with the help of graph, how it works. Okay, so let us consider the EMF is given by E is equal to E naught sine of omega t. Since current in the inductor lags behind the voltage by pi by 2, so current I is given by, this is E naught sine of omega t minus pi by 2, or that is equal to I naught minus I naught cos of omega t, right? So power is given by E into I. This is minus E naught I naught sine of omega t into cos of omega t. Now total work done, if we find out, work done is given by 0 to t. This is minus E naught I naught multiplied by 2 and divided by 2. We get sine of omega t cos of omega t dt, right? So this is minus E naught I naught by 2. This is the formula of sine 2 omega t. This is sine 2 omega t integration from 0 to t dt. We have already done this many times, that integration of sine of 2 omega t dt is 0. So again we can solve it. This is minus E naught I naught by 2. Sine 2 omega t integration is 2 sine a cos b is sine 2 omega t. Okay, so this is cos of 2 omega t minus cos of 2 omega t by 2 omega. This is 0 and this is upper limit. So this is minus minus becomes plus. This is E naught I naught by 4 omega. Now when we put upper limit, this is cos of 2. Omega is 2 pi by t into upper limit is t minus cos of 0. Now when we solve it, we will get 4 pi. Cos of 4 pi is 1. So E naught I naught upon 4 omega into cos 0 is 1, and cos 0 is 1 and cos 4 pi is also 1. 1 minus 1 is 0. So hence we have proved that work done in that case is 0, or we can say that average power, rate of doing work, is also 0. So average power associated with an inductor circuit is 0. Let us now understand the magnetization and demagnetization of inductor with the help of this graph. Now you can see here, since current I is lagging behind the voltage by pi by 2, so in that case you can see here the current starts from mean position, okay, while EMF starts from the maximum position. So in that case the current is lagging behind the voltage by pi by 2. You can also understand by this circular method. In that case also, if voltage is at this point and current is at that point, it means current is lagging behind the voltage by pi by 2. So that is why we have started the EMF curve from the maximum value and the current from the mean position, and we have plotted the graph at various time position, that is t by 4, 2t by 4, 3t by 4 and 4t by 4. Now you can see that during 0 to t by 4, during 0 to t by 4, you can see that current I is increasing and reaches to maximum value at t by 4. And if you can see that current EMF E is decreasing, but it is still positive. So this lie on the positive axis. So we can say that both E and I are positive. So power is positive. Since E and I are both positive, so power is positive. Power is positive means energy is absorbed from the source. Energy is absorbed from the source. Means in that case the inductor is get magnetized, okay, because current is increasing. Now if current is increasing through the solenoid, in that case more magnetic field is being induced, and we can say that inductor is being magnetized. Okay, now from T by 4 to 2T by 4, from T by 4 to 2T by 4, now you can see that current I is still positive, but it is decreasing, okay, and EMF curve you can see that it is negative. Now current is positive, rate of change of current is decreasing, no doubt, but current lies on the positive axis and EMF is negative, so the product of E and I is negative, that is power is negative. So in that case I is positive while E is negative, so power P is equal to IE is negative. So we can say that in this case the energy is being returned to the source. Energy is being returned to the source, and we also can say that inductor get demagnetized. Since we can see that the current is decreasing from maximum to zero value, current is being decreased through the solenoid inductor, in that case the value of magnetic field goes on reducing, and we can say that the inductor gets demagnetized. Now again from the time period 2T by 4 to 3T by 4, from 2T by 4 to 3T by 4, now you can see here the current is negative, decreasing, current is flowing in the opposite direction and it is in negative axis, and EMF increases but it is still in negative direction. So we can get both E and I are negative, so power P is equal to I is positive, that power is positive. So in that case we can say that energy is absorbed by the source. And in case of inductor we can say, if initially suppose in case of inductor the current is being entered from this end, okay, and it is get magnetized and demagnetized during the 0 to 2T by 4, at the time 2T by 4 to 3T by 4 the direction of current is being changed. It means now current is being entering from B to A, it is entering from B to A, the direction of current is reversed and it is increasing in the reverse direction, so inductor is getting magnetized. Similarly during the time period 3T by 4 to 4T by 4, you can see that here the current is still negative but increasing in negative direction, okay, and voltage is positive, so the product of power and current is negative, okay, so power is negative. So in that case power is negative, so energy is being absorbed, returned to the source. And if we see that here current is decreasing in the negative direction, means current when it is entering from B to A, in that case current, the magnitude of current is decreasing. So since magnitude of current is decreasing, it means the inductor is being demagnetized. So this is how in case of inductor the magnetization and demagnetization takes place.